Hello everyone. We have another video to solve this problem right here. We have Peter and Judas at were racing each other. At time is equal to 0, both were at the same spot. At time is equal to 0, Peter was running at 1 meter per second, accelerating constantly by 2 meters per second squared, while Judas was running at 5 meters per second, having constant acceleration of 1 meter per second squared. If the finish line is 100 meters away from their location at time is equal to 0, who will reach the finish line first? Okay, so let's try and solve this problem. So what this problem states is that we have two persons, Peter and Judas, racing each other. The question now is, who will reach the finish line first? To solve this problem, let's divide our given into two parts. One for Peter, one for Judas. Okay. Peter initially was at time 0, Peter was running at 1 meter per second. We can have this as our initial velocity or VO, while your VO for Judas is 5 meters per second. Okay. So obviously, initially, Judas was running 5 times faster than Peter. Okay. Next, they were both accelerating constantly. We have, for Peter, we have the acceleration is 2 meters per second squared, while for Judas, it was only 1 meter per second squared. So, although Judas was moving initially faster, Peter had a faster acceleration, meaning initially Judas will be ahead, but as the longer time moves on or the longer the race becomes, the faster Peter will be. So there will come a time where Peter will be moving faster than Judas. But the question is 100 meters away, 100 meters enough for Peter to catch up to Judas? No? So the question is, who will reach the finish line first? We have the initial velocities, the acceleration, and we know that they need to reach or they need to cover a distance of 100 meters. So we can have it here as their distance 100 meters. They both need to finish the 100 meters. So given this initial velocity, their acceleration, the distance they need to travel, we need the time. Now why do we need the time? If we compare their time, meaning how much time will Peter consume to travel a distance of 100 meters given acceleration and velocity, same with Judas, if we compare their time, the person with the smaller time will obviously be the one who will reach the finish line first. So I repeat, the person with the smaller time will be the one who will reach the finish line first. Okay. So how do we solve the time they need to travel a 100 meter? Since they are moving at constant acceleration, then we can use x is equal to xo plus vot plus 1 half at squared. Okay, where we have the initial position, the final position, plus the initial velocity times time plus 1 half acceleration times time. We have the initial velocities for both, we have the constant acceleration for both, and for the distance they need to travel, since the finish line is 100 meters away from their location at time 0, meaning at time 0 they were at the same spot, and from that spot the finish line was located 100 meters away from that. So if we consider the initial position to be at time is equal to 0, so their initial position is xo is equal to 0. Okay, so let's try and solve for each. For this one, we have 100 is equal to 0 plus initial is 1 times t plus 1 half acceleration is 2 t squared, while for the other one, this is 100 is equal to 0 plus initial velocity is 5 times t plus 1 half times 1 t squared. So rearranging them, we would get, this is now t squared plus t minus 100 equals 0. T squared because 2 times 1 half, that is 1. So 1 t squared, 1 times t, that is t. Transfer 100 to this side, you have negative 100. Let's do the same for the other one. This becomes 0.5 t squared plus 5t minus 100 equals 0. 0.5 t squared plus 1 half times 1 is 0.5. 5 times t is 5t. Transfer 100 to the other side, we have minus 100. So we now have this one, an equation with only one variable. So we need to solve for t. So let's go to our calculator, mode 5, equation. We'll choose 3 because there's only one variable but a power of squared. So 3. ABC. So I repeat, for when using equation, you need to follow this placement. A plus B plus C equals 0, which we are following. A plus B plus C equals 0. The A is the coefficient of the squared, B coefficient of the only one, and C is the constant without the coefficient or without the variable. So 3. Oops. Okay. Let's start. T squared, the coefficient is 1. So you have here 1. Coefficient of B is also 1. So we also have it 1. And then the negative 100. Negative 100. Let's get the answer. The first value is 9.51. The second value is negative 0.51. So we'll only consider the positive time. So we have a time of 9.5 seconds. So we have a time of 9.5 seconds. Time of 9.5 seconds. Okay, let's move with Judas now. We have 0.5, 0.5. We also have 5, 5. And then negative 100, negative 100. So you have a time of 10 seconds, while the other time is negative 20. Consider only the positive time. So you have 10 seconds. Yes, 10 seconds. So obviously Peter just needs 9.5 seconds to reach the finish line, while Judas needs 10 seconds to reach the finish line. So Peter will obviously reach the finish line first. So the answer is Peter. It's now the answer. Okay?